Hey everyone, Mr. Fugay. Welcome to this video where we're going to talk about central angles and arc measures. So as you can see at the top, here is a summary of what we're going to be talking about, specifically about central angles and how we can use them to find our arc measure of circle. That word measure will be important. I'll talk about that shortly. But let's start with what we already know, and that is, what is a central angle? A central angle is an angle whose vertex is at the center of the circle. So the example there on the right, angle DEF, and I'll highlight that in red for you. Angle DEF. The angle that's formed right there, 78 degrees as it's marked, is considered a central angle. One of the other things I do want to add to this, though, is that the sum of all central angles inside of a circle must equal 360 degrees. So, for example, if I have another circle drawn here, and let's just draw a couple segments here, like so. So if I say this is 20 degrees, and I say this is, well, let's talk about this line right here. This, because it's going through the center as a straight line, would be the diameter. So we'll talk about that. Let's make this 10 degrees. Let's make this 80 degrees. And then let's see if we can fill the rest of these in. So everything has to add up to 180. That red line that I drew through the center is actually creating a semicircle, which means half the circle, so half a circle, is equal to 180 degrees. So that's another little side element we want to talk about here. So based on the fact that it's 180, subtract 20 away means the angle right here would be 160 degrees. Now you could do one of two things to find that last missing angle, and that is you could add the 80, the 20, the 160, and the 10 together, and then subtract that from 360, or we could use the fact that this red line, once again, is half a circle, and so the left half also will add to 180. So since this is 80 and this is 10, that's 90 degrees. So then this angle right here, not drawn very well, but that angle would be 90 degrees. So now if you added up all 5 of those angles together, you would get 360. We'll see more of that on the next page. But now, we've learned what central angles are, and we also now know the sum of central angles is 360 degrees inside of any circle. Let's look down at what an arc measure is. So a central angle will always form an arc. And I'll come back to this example very quickly to mention that the angle 78 is cutting through this arc DF. So when we're looking at arc DF and angle DEF, what we want to conclude is that the measure of an arc is the same as the measure of the central angle. So since angle DEF is equal to 78 degrees, what that infers is that the arc formed by that central angle, arc DF, will also equal 78 degrees. So we can mark that over here, that the measure of arc DF, 78 degrees. To find the major arc, so to highlight that here, that's going to be DGF, so we'll follow this red arc all the way around. Well, that's just simply going to be 360 minus 78. And so you subtract those, and that's going to give you the major arc, which again comes back to the idea that all central angles must add up in a circle together to get 360 degrees. So this last arc would be 282 degrees. Continuing the conversation here, as we said before, the measure of a semicircle is 180 degrees. A semicircle is formed by a diameter. So a diameter drawn through the circle, so here it is a chord that goes through the center, is going to also cut the circle in half, which makes the top central angle 180 and the bottom central angle also 180. Now, before we look at some practice problems using this idea of central angles and arc measures, I do want to mention something very important here, and that is that there is an arc measure, which is what we're talking about in this video, in this lesson, but then there also is an arc length. And so it's really important to denote the difference between the two. Arc measures is the measure of an arc in degrees, so it's an angular measurement, versus arc length, the word length, is a unit of measurement. So it's or more specifically, it's a unit of length. So that means it can be measured in centimeters or meters or feet or yards, etc., etc. So these are two different ways to measure an arc. One way is by its degree measure, and the other is actually by its actual length. Like if we had a ruler and bent the ruler around to measure it. So we're not going to learn arc length tomorrow, but later we will learn how to find arc length as different to arc measure. Okay, let's do this first set of examples, and then you're going to try a few where you pause the video and try these out. So here we go. So as I mentioned, I'm going to highlight my diameters here in colors. So like AB is a diameter. Then I'll use a different color, maybe we'll use purple, to denote that DE is also a diameter. So keep in mind that diameters create 180 degrees. The reason that's helpful is because if I use the purple diameter, okay, this is 50 degrees, and then this angle creates the rest of that semicircle. So then this is just going to be 180 minus 50. So that's going to be 130 degrees. So this arc EA, which is I don't think one of the ones listed, is going to be 130 degrees. Let's go ahead and see what they're actually going to look for here. So we want to find arc BE. Well, since we already found this to be 130, let's look at that green arc now. So the green here is 130. This angle right here would then also be 50 degrees. There's two ways to look at this. One is that green diameter AB creates a semicircle. So the arc AE and arc EB would have to add to 180. Or you might notice that this line DE and this line AB, these are non-adjacent angles that are across from each other, which makes them vertical angles. So yes, that is still a thing that we can use here as well. So that's 50 degrees. Okay, the next one they're asking us to look for is CBE. So C to B to E. Well, since we know this is 50 and we know this right here is listed as 90, all I have to do is add those two together, and that would tell me that the arc would equal 140 degrees. So let's clear out all this work we've done. I'm going to go back and fill in the answers we've gotten so far. So this was 130, and then this was 50. The last thing they're asking us for is arc ACE. So A to C to E. Now you notice we did not find arc DC yet, and while we easily can find it, this is not necessarily asking us to find that. So another thing we can do here is that since we have this major arc ACE, it includes everything except, so everything except arc AE. So one option that you can do for this is you take 360, which is the entire circle, and subtract arc AE's measure. In other words, we're going to take 360, and subtract 130 from it. So 360 minus 130 is going to be, what's that, 230, I believe? 230 degrees for that last one. Okay, so now it's your turn. We're going to look at another diagram here, and I want you to go ahead and pause this video and try to answer these questions. Answers so far, and then we'll talk about the last one. So we'll start here with arc CD. So arc CD starts at C, goes to D, and since that right angle symbol was there, it means the central angle was 90, which then makes the arc equal, the arc measure, equal to 90. So there it is. Next was FD. So we're going to start at F and then go the shortest distance we can get to D, which is going to be around this way. Now there are two numbers we need to know. First is a 34, which is F to E. And then ED ends up being 90. And the reason that is because of the diameter CE. So that cuts the circle into two equal parts. Since this was 90, that automatically makes that 90. So 90 plus 34 is 124. Now for the next one, and I'll use a blue maybe for this one just to show you what this looks like. So it says DCF. So we're going to start at D. We're going to go in the direction of C and then all the way around to F. What you'll notice is that major arc is everything except the FD that we just found. So all I did is I took my total 360 and subtracted the 124 away to get to 236. Now, just like the other ones, there got to be too many things on here, so I'm going to erase everything and just simply fill in that this was 90, this was 34, this is 90, and I think that's everything we have found. I believe over here this is 90 as well. So the last thing we need to find is arc GDF. So G to D first, and then to F last. So once again, we have another situation where it's everything except one little piece. So it's everything except GF. So what I'm thinking here is we do 360 minus whatever GF is. So let's go ahead and do that. So GF, how would we find that? Well, I know this is 34 and I know this is 90. We have our diameter cutting through here. So if I subtract 180, that's half a circle, minus 90, minus 34, it leaves this last section here to be 56. So since GF is equal to 56, the easiest way I would do this is 360 minus 56. And that means that the remaining arc measures of all the other pieces is going to be 304 degrees. So that'll take us to our last problem here that we'll talk about in this video. And that is finding X here and then also finding the measure of arc HD. Well, the measure of arc HD, I believe, has already been given to us here. So we start at H, we go to D. You can see that that's already listed as 15 degrees. That's going to be an important factor as we look at this next section. So we want to figure out what 18x minus 2 is equal to. So let's find what that is, and then we'll solve the equation last. So since GF here, whoops, I don't know how that's a heart there, but let's try it again. GF is going to be 103 degrees. Since we have, once again, another diameter that slices through here, EF is just going to be 180 minus 103. So when I take that in my calculator and we subtract those away, we see that this is going to be 77 degrees. Now, the reason why that's helpful here, and some of you might have already seen some other relationships going on, but what I'm going to use here then is another diameter, HF, that cuts through. Since this is 77 and this is 15, to figure out 18x minus 2, sorry about that, 18x minus 2, we're going to take 180, which is, again, half a circle, minus 15 minus 77. And so when I do that calculation, we're going to end up with an answer of 88 degrees. So this last arc is equal to 88 degrees, and that's what my equation is going to be set up for. So we'll add 2 to both sides to set up the equation. 18x equals 90. And last but not least, we're going to take and divide both sides by 18, and our final answer is going to be 5. X equals 5 here. So that summarizes and concludes central angles and some examples associated with it. So take this information and take this to find arc measures and measures of central angles. Thank you for watching.